Okay, we're going to look at prime factoring to get LCMs, or least common multiples. Again, I'll probably take the same numbers like 12 and 28, and I'll prime factor those, and this should go pretty quickly after you do this a couple times. And 28. Okay. Well, and I showed that Venn diagram in my other video, but to go through that again, when we organize our prime factoring, I can do this in a Venn diagram method. In the books, usually they line up the prime factorizations and they say only use your common prime factors once while you're multiplying to get the LCM. Well, this kind of takes care of that. If I have 12 in this circle is all the prime factors of 12, and in this circle are all the prime factors of 28. Well, I can organize this way. It just gives me a way to organize this data in a sense. Is that, well, I got a 2 and a 2 that are common here for prime factors. That means they're going to be placed in that overlapping portion of the circle. Well, what's left here for 12? I got the 2 and a 2. I need a 3. And here I got a 2 and a 2, and what's left in here is 7. And I did talk about that. If I had 12 28ths as a fraction, I can just cover that up right there, and there's my simplified fraction. This basically says, hey, here's your overlapping common factors. Let's rewrite those as ones, right, as 2 over 2 and 2 over 2. I simplify that fraction. Just a little bit of review of simplifying fractions, or getting the simplest form, which is the definition is they are the only common factors between the numerator and denominator is 1. So, but in this case, I want to get the least common multiple between these two. It might be something, here's what kind of problem I might have. If I have 1/12 plus 3 28ths, and I want to add those things. Well, to get fractions, the rules for adding fractions is that I have to have a common denominator. Now I could say, I could get all the multiples of 12 and all the multiples of 28. You know, take 1 times 12, 2 times 12 is 24, 36, and so on. And I could list all those out. And then I could list the multiples of 28. And when I get a common one, or one that's the same, and hopefully the least one, the first one I come across that's common, that would be my least common multiple. Okay? So I look at the multiples and everything else. Well, there's a way to do this with prime factorization, because if these numbers get big, you could list a lot of multiples before you find something that matches up. If I organize my prime factorization in this way, I can say, well, here's all the factors of 12. You know, like if I cover up this part again, if I cover up that, here's a circle, 3 times 2 times 2, that would be 12. If I cover up that top part of that circle, there's the bottom circle, which is 28, 2 times 2 times 7. If I multiply everything that I see here, that'll be my LCM, my least common multiple. So in this case, now I don't have to just go 3 times 2 times 2 times 7. I already know what this circle multiplies to be, right? It's 28. So I just take 28 times 3 and I'll get 84. So what does that mean? I need to rewrite each one of these fractions as something over 84, if I did that right. 28 times 3 is 60 plus 24 is 84. Okay? So what I need to do is rewrite each one of these fractions as something over 84. Well, how do you do that? What's the number that I can multiply by that will not change anything? That's the identity of multiplication. So I'm going to rewrite this and say, well, I need to get this 1/12 to change to something over 84. If I keep this diagram here, I already know that, hey, here's 12 is in this circle. What do you need to multiply by to get 84? It's right here, right? Here's my 12 is in that circle. So 12 times 7 is 84. So I need to take the denominator times 7, and I'll get 84. Well, what again is the number that I can multiply by that does not change the value? It's 1. And there's an infinity of ways that I can write 1 in fractions. So I get this multiplication, which is really 1/12 times 1. So I end up with 1 times 7 is 7, 12 times 7 is 84. So this proves basically that 1/12 and 7/84 are exactly the same position on a number line. They represent the exact same value because I'm really just multiplying by 1. Well, same thing with the 3/28. If I take 3 over 28, and I got to multiply that denominator by something to get 84, well, I know that that's going to be this 3. So I take that times 3, and what's the number I can multiply by? Is 1. So I have to make that fraction equal to 1. So now I got 3 times 3, which is 9, over 28 times 3, which is 84. Here are my two new fractions to do this addition. So, and what's the rule on it? Once I have the same denominator, the rule is I just add the numerators. So this process of getting a common denominator, right, and hopefully our least common denominator, well, we can use prime factorization. We can organize those prime factors to basically tell us what the least common multiple is going to be, and then I can still use this as a tool to say it'll indicate what's the next fraction that I need to multiply by that's equal to 1. Okay, by using this, so I don't have to redo all this work. I see students do this all the time. They'll figure out the LCM is 84, and then they'll go, well, 84 has to divide into 12. How many times? Well, you just generated it in an organized ways. Use that organization to say that I know that it's 7. Okay? And it'll save you a lot of work, a lot of errors, because you don't have to divide, really. We have all the multiplications we need all laid out for us if you understand how this works. So to do this addition, then it'd be 7 plus 9 is 16, 84ths. Then what's the next thing that I have to do after I add a fraction? Well, it needs to be in simplest form. Well, here goes that prime factorization. If I want to make sure that I don't miss anything, I can prime factor each one of these numbers, 16 and 84. Which is 16 is 2 to the 4th power, 2 times 2 times 2 times 2, if I said 4 times, right? And 84 is even. I could start there. Well, that goes in there for the 2 times. So that's even again. So 2 goes into that. Goes in there 21 times. And actually, I know what the prime factorization. I don't know why I'm doing that for 84. Why would I have to do that? Here is prime factorization of 84, right? So I could even use this again. If I kept my work, I could say, well, I don't have to do this. Here is the prime factorization of 84. Okay? And so they do that. Well, when you simplify fractions again, I could do this again, and then I could make a circle. I'm going to probably run out of space here. But I could do this organization again and put all the prime factors of 84 and 16 together. Well, the common ones, I got a 2, and so there's 2 2's. In the 16 up here, I have 2 and a 2 again, and I use these 2's, and I got a 3 and a 7. Well, if I cover this up, I get 2 times 2 over 3 times 7, which is 4 over 21. That's my simplified fraction. See how these things can really be useful, and I get a way to not have to do a lot more math. And I think I'm probably scrolled off the screen there a little bit. Okay? So I'll save this again as a separate video. This is a good reference. There's also a lot of other videos and techniques about prime factorization. I like these Venn diagrams. They can be real useful tools, especially when we're dealing with fractions. And good luck.